All right, welcome back. Dr. P here, and in this lecture we're going to move into Chapter 11 and look at substitution reactions. Specifically, we're going to look at nucleophilic substitution reactions. And I think it's best to start by just looking at some examples. So let's go ahead and take, let's do this. Let's do CH3 Br plus, let's do Cn minus, and we will get a substitution and get CH3Cn plus Br minus. And in particular here, we have the cyanide is our nucleophile, and the CH3Br is our substrate, which is also the electrophile. The bromine is the leaving group, because that's going to leave. It's going to be kicked off of the methyl bromide when the cyanide adds. All right, a different example is CH3 CBr plus Cn minus, which gives us a similar product. And again, we've got the same nucleophile, and our substrate is now our T-butyl bromide, and we still have bromine as the leaving group. Now, one interesting thing to note is though even though these reactions seem very similar, we're swapping a cyanide for a bromine, there are some differences. And in particular, if we look at the rate law for the first reaction, we see that we have a second-order rate law. The rate is dependent on the rate constant times concentration of one reactant times concentration of the other reactant. For this other substitution reaction, we find that it is first order. So second order for the first one and first order kinetics for the second one. That is, the rate only depends on the concentration of, in this case, the substrate. Now, thinking back to Chem 1b, what does it mean when we have different rate laws? Well, different rate laws mean different mechanisms. So the rate law tells us what's going on in the rate determining step. And so what this reaction is saying is that the rate determining step involves these two guys colliding. Whereas in this other reaction, the rate determining step only involves the substrate falling apart, that is, losing the leaving group. And so if we were to plot what these energies look like, or what these reactions look like in a reaction progress diagram, we'd see that this first one here, there'd be a hump, that's our transition state, and that is our two reactants colliding, and we go through the transition state and then we get product. In this other reaction, we'll go ahead and our rate determining step is actually the bromine falling off, and we get an intermediate. And then that intermediate carbocation then reacts with the nucleophile, that's the next step, and then we get our product. Now these reactions are known by different abbreviations, and we call them SN2 and SN1. So that stands for substitution nucleophilic second order, or substitution nucleophilic bimolecular, because two molecules collide in the rate determining step. And then SN1 is substitution nucleophilic first order, or substitution nucleophilic unimolecular, because in the rate determining step we just have one molecule that falls apart. Okay. So this is the overview, and we'll look at some details of each of these in turn. And I think I might do separate lecture videos for each of those. So we'll start with the SN2 reaction first. So until next time, stay safe. Bye now.